In this video, we're going to look at the following problem. So we're going to work at a drug company, and we're testing a new drug. We're going to break 1,000 people into two even groups. In the control group, 100 people got better, and in the treatment group, 125 people got better. So does this provide evidence that the alpha equals 0.01 level that the new drug is effective? So again, what we're doing is we have two groups here. We have our control group, and we have our treatment group. Now the control group, those are people that are getting a placebo, they're not actually getting our drug, whereas in the treatment group, those are the people who are getting our drug. Now in this group, we had 100 people got better, so that's our X value, and in our treatment, we had 125. Now we took 1,000 people and broke them into the groups evenly. So that means that in both groups, our N is 500. Now it is true that more people got better in our treatment group, but we want to see, is that number statistically significant, or could it just have been from random chance? Now because we're using two separate groups, we do have to use a two-proportion hypothesis test. So I'm going to let P1 be our control group results, and P2 be our treatment results. So our null hypothesis here is HO is that our two proportions are equal to each other, or in other words, there is no statistical significance between the results that we got. They're the same results. Even though our numbers might be slightly different, that difference could be attributed to just random chance. Now on the other side, we have HA. Our alternate hypothesis is that our P1 is going to be less than P2. Or more people got better with our drug, because again our drug is P2, than got better on just the placebo. So now that we have that, we'll go ahead and go to our calculator. So we'll go back to stat, go over to test. We're going to go to option 5, the one proportion z-test. And so, actually we're doing the two proportion z-test. So this is actually option 6. Sorry, I misspoke. Because we do have two groups we broke this into, we do have to use option 6, which is the two proportion z-test. So our x1 is our x in our control group, because that's what P1 is. So that's 100. Our n one is the amount of people in our control group, which is 500. So in X2, that's the amount of people in our treatment group that got better, so 125. And our N2 is 500. And we want P1 to be smaller than P2, so that's this one here in the middle, because again, P1 less than P2. So we go down to calculate, and it'll give us our results. So here's our results. Our p-score, or p-value, equals 0.029. Now we compare that to our alpha, and in this case alpha is 0.1. It's given right there. So our alpha is 0.01. So because our alpha is 0.01, we compare that to our p-score, so 0.01 and 0.029. Our alpha value in this case is less. So because this is less, we fail to reject the null. Which means that we do not have evidence that our drug is more effective. Even though, if we look here at our numbers, even though we had more people get better on our drug than in the control group, this amount of people could just be attributed to random chance and not our drug actually making them better.